Welcome to Zuluba Consultants and to this live presentation that we are going to discuss this question that reads, a white powder is analyzed and found to contain 43.64% of phosphorus and 56.36% of oxygen by mass. The compound has a molar mass of 283.88 grams per mole. So we have been asked to find the empirical formula. So for us to find the empirical formula and the molecular formula, we need to do certain steps that can help us to achieve this goal. The first step is looking at the percentages that we have been given. These percentages gives us the composition by mass of the two elements that are in this compound. So the two elements that are in this compound, we have phosphorus and oxygen. So the percentage by mass, so we are saying the mass of the two is for phosphorus is 43.64 grams, and for oxygen it is 56.36 grams. So these are the percentage by mass of the two that we have been given. Now, after you have the percentage by mass, the next thing is to find the number of moles. So let's get the number of moles of the two elements that we have. So basically, how do you calculate the number of moles? We say number of moles is equal to mass divided by atomic mass. So the mass we have is 43.64 grams. Then the atomic mass of phosphorus is 30.99 grams per mole. And then we come to oxygen, 56.36 grams. The atomic mass of oxygen, it is 15.99 grams per mole. So we now have these two, so we can find the number of moles of the two. So we are saying 43.64 divided by 30.99. It is giving us 1.41 moles. 1.41 moles. Then for this other side, when we are saying 56.36 divided by 15.99, it gives us 3.52 moles. So we have 3.52 moles there and 1.411 moles there. So after you have this number of moles, we can find the ratios between the two by dividing with the smallest. So we are dividing with the smallest. So the smallest here is 1.41. So I say 1.41 divided by 1.41. And this side will say 3.52 divided by 1.41. So when you divide these two, they will give you 1. Then this other side, 3.52 divided by 1.41. It is giving us 2.5 as the ratio. So these are the ratios of the elements that we saw, when you use 1 of the phosphorus, 2.5 of it, of oxygen should be used up. Now these are not whole numbers, so we need to multiply them with a figure so that we can get all numbers. So if we multiply these by 2, when you multiply them by 2, you will find that you will have 2 and 5 there. So 2 and 5 then becomes the beta numbers that should be used when it comes to coming up with the empirical formula. So if you have 2 and 5, then the empirical formula will be P2 then O5. So this is the empirical formula that we have. We have P2 and O5 there. Now, after you have this empirical formula, the next thing you need to do is to find the molecular formula. Now, for you to find the molecular formula, we have already been given the molar mass of the molecule. So there is a relationship that X multiplied by the molar mass of the empirical formula should be equal to the molar mass of the molecular formula. So we have the molar mass of the empirical formula. So the empirical formula that we have is P2O5. So we can find the molar mass of this, that's the mixture of this. We have 5 atoms of oxygen multiplied by 15.99. Then for phosphorus, we have 2 atoms of phosphorus multiplied by 30.97. So let's say 5 multiplied by 15.99, it gives us 79.95. Then the other one is 2 multiplied by 30.97. It gives us 61.94. So what is the total there? 61.94 plus 79.95. It gives us 141.89. So this is the mixture of the empirical formula. So this empirical formula has 141.89 grams per mole. So now that we have the molar mass of the empirical formula there, we can now get the X here and put the molar mass of the empirical formula, which is 141.89 grams per mole. This should be equal to the 283.88 grams per mole that we have been given as the molar mass of this molecule. Now at this point we can multiply, or rather divide both sides by 141.89 grams per mole. Even this side 141.89 grams per mole. So this will simplify, then we'll have X is equal to, so we are dividing 283.88, dividing it with 141.89, it is giving us the answer of 2. So the multiplying factor is 2. So this simply means this empirical formula should be multiplied by 2 for us to get the molecular formula. So we are saying 2 The empirical formula that we have is this. So when you have this, we are saying the molecular formula will be equal to P4O10. So this is the molecular formula. So we have now summarized the two, and you can conclude that the empirical formula is P2O5, while the molecular formula is P4O10. So these are the empirical formula, and the molecular formula that we needed to find is we convert the percentages into the masses, knowing that these are the masses of each element that is in this compound. Thereafter, we use these masses to come up with the number of moles of each element in this analyzed compound. Then we divided the number of moles with the smallest number of moles. So the smallest number of moles is helpful to come up with the mole ratio. The mole ratio was 1 to 2.5, so we had to multiply that by 2 to get whole numbers, which tend to 2 to 5. So we had 2 to 5 now, so 2 of phosphorus and 5 of oxygen. Thereafter, we find the relative molecular mass of P2O5, which gave us 141.89 grams per mole. Then we said X, open bracket, molar mass of the empirical formula, close bracket, should be equal to the molar mass of the molecular formula. Then we managed to find that the multiplying factor is 2, so we multiplied the empirical formula by 2 and found the molecular formula. So this is how far we can go in this video. Thank you so much for watching, and look forward to more live streams. Until next time, it is bye-bye.